Many people have had some type of medical imaging test done at some point in their lives. Out of all the imaging tests available, x-rays are the most prevalent, and oftentimes that exposure is about half of the average American's exposure during their life, according to the National Institute of Biomedical Imaging and Bioengineering. Now, oftentimes when we think of radiation, what do we think of? Well, probably the aggressive cancer treatment. But radiation goes beyond that when it comes to medicine. It's not always as damaging as we often think of it to be. And in fact, X-ray imaging tests have helped medical professionals significantly to determine and to diagnose different medical issues and even expand the different types of tests to do these things. My name is Erica Cutrufo, and I am a student at the University of North Carolina at Chapel Hill, and I am a pre-medicine student studying chemistry. Now, I would like to discuss today what radiation is and the different types of X-rays testing specifically, and how X-rays use radiation. Now, to begin, what is radiation? Well, radiation is energy traveling as waves or subatomic particles, which are electrons, protons, and neutrons, and these just vary in charge, and they combine together to create different kinds of atoms. Now, the type of radiation in medical imaging is called ionizing radiation, and this is specifically the removal of electrons, which then emit some sort of energy, and that would be radiation. Now, radioactivity is just the umbrella of this, and this is just discussing spontaneous disintegration, which would be such as the electron popping off and creating energy. Now, my experience began last year when I conducted this lab, and this was a lab dealing with a bacteria sample, and I took 2 different petri dishes. This is the control group. No UV light was exposed to this culture, and in this one, 2 minutes of UV light was exposed. And as you can see, with the original population, it was a pretty thick amount of growth. And then when 2 minutes of UV light was exposed to this culture, it whittled down to about half. And this is because the UV light exposure had created mutations in the bacteria's DNA. Now, the thing about this is it creates dimers, and therefore replication and transcription can no longer occur. And this essentially is just how cells continue to replicate in the body and in bacteria. But the thing that's different about humans versus bacteria is humans can't repair themselves after that. Once the damage is done, it's done. It kills the cell. Now, with bacteria, they do have a repairing mechanism to a certain extent. Now, at 2 minutes, it could potentially grow back to almost the original size. But if I were to have exposed this sample to, say, 5 minutes or 10 minutes, at 10 minutes, it would have likely killed the entire population. Now, this goes to show that this technique, along with the founder of X-rays, which is German physicist Wilhelm Röntgen, he discovered this in 1895, and this was entirely on accident. But the technique is similar as I conducted with bacteria. Now, at the Global Cardiology Science and Practice, Danya Muhammad details how he discovered this. And he discovered this using a gas discharge tube and a black piece of cardboard. Now, he stuck a couple of objects under to see what would glow, what image would pop up. And he became curious and stuck his hand there, and he ended up producing this image. And of course, in modern medicine, we have a much more detailed image of hands or bones, whatever, that we are looking at. And part of this has to do with, obviously technology. So we go from x-rays, just looking at general things like the bone. Now we can see if somebody has pneumonia or if they have abnormal mass. Dentists often use this to see overcrowding. And even more specifically, we now have things like CT scans, which are computed tomographies. And these require the use of a computer to create even more detailed images. Now, as you can see here, this is an X-ray, and this is a CT scan. Now, this is the brain, And as you can see here, there is some sort of mass, which is likely to be a tumor. Now, you can see also there's white here, gray, and then there's black. Now, why is that? Well, critical care nurse practitioner William Pizzotti discusses X-ray physics. And basically, the physics behind this is radiological density. The more dense or radiologically dense a bodily tissue is, the more it will absorb X-rays, and the vice versa. The less dense it is, the more it will just go straight through. For example, this right here, these two cavities here, are the lungs. They are air-filled cavities. And they're black because the X-rays are going straight through. Whereas here in the ribs or the skull around the brain here is completely white. And that is because there's so much calcium that it makes it radiologically dense, and therefore it absorbs almost all of the X-rays. Now, radiation is all around us. Its involvement in medicine has contributed to prolonging our lives with painless early detection abilities. I've explained how radiation is produced, the different types of imaging tests that are available to us, and remember that X-rays are the most prevalent form of radiation that we come in contact with through our lives. Now, this is not something to fear. This is something that we need to learn more about and be more aware of, as it can save your life one day. It could save someone you know or somebody around the world. Thank you.